Hey guys, in this video all I'm going to do is solve all of the problems on Worksheet 3, the review for the final exam. I'm going to go pretty quickly, but you are more than welcome to pause the video or rewatch sections if you'd like. Number 1 and 2 are both inequalities, and basically when you're solving an inequality, you could treat the inequality basically the same as an equation. The only main difference is you need to make sure that you keep the symbol pointing in the right direction. And on top of that, you need to make sure that if you divide both sides or multiply both sides of an inequality by a negative number, then you have to reverse the sign or the direction that the inequality symbol is pointing in. But you can notice as I'm solving this first inequality, I am treating this just like an equation. I'm adding 3 to both sides. I have 4x is greater than 12. I'm dividing both sides by 4. So I'm getting ahead of myself there. I'm thinking that the answer is going to be 3, which is why I started writing 3. So basically what we just ended up getting is x is less than -1 or x is greater than 3. Now that's called inequality notation. It makes sense that it's inequality notation because we wrote our answer in the form of inequalities. Now if you thought about this, what this looked like on a number line, the solution set, essentially what you have is the set of numbers that are smaller than -1, but not including 1, and the set of numbers that are bigger than 3, but not including 3. So when we talk interval notation, that's the set from -infinity to -1, joined with the set from 3 to infinity, because their second set is the set of numbers that are larger than 3, but not including 3. Now we could do a similar thing for number 2 here. It's just that this is an AND inequality. So we have x is greater than 1, and when we add 1 to both sides in the second equation, x is less than or equal to 4. So we have the set of numbers that are smaller than or equal to 4, but bigger than 1. So in inequality notation, you could write this as 1 is less than x, which is less than or equal to 4. Or if you want to write this in interval notation, it's the set of numbers from 1 to 4, not including 1, but including 4. For a quadratic, like we have in number 3, we can factor out a -1, and we're left with a 5x squared minus 3x minus 2 is equal to 0. Now for this remaining quadratic inside of the parentheses, what we can do here is we can make a diamond, put a -10 up top and a -3 on the bottom. We want two numbers that multiply to -10, but add up to make -3. I think -5 and 2 will do the trick. Now we'll throw this into a box. The reason that we're using a box is because there's a leading coefficient other than 1 in front of x squared. There's a 5 in front of the x squared. So that will necessitate us using a diamond and a box to make this work. Now we factor out GCFs, take out an x, a -1, a 5x, and a +2, and we have our factorization. We have -1 times the quantity 5x plus 2 times x minus 1. This is an equation that's equal to 0. When we have our factors equal to 0, the zero product property says that if something multiplies to make 0, each of the parts must equal 0. So we have 5x plus 2 is equal to 0, we have x minus 1 is equal to 0. That's going to end up giving us that x is equal to -2/5 when we solve the first equation, and x is equal to +1 when we solve the second equation. Number 4 asks us to use the square root property in order to solve. Now the square root property just means taking the square root of both sides of the equation, but the only way that we can do this is when we make sure that we have the squared part all by itself on one side of the equation. And that's what we've just gotten right here. You can see x squared is equal to 16. Now we could take the square root of both sides. Not before that, but now we could take the square root of both sides. Don't forget your plus minus, and you have x is equal to plus or minus 4, positive or -4. Same idea in part B, but now the squared part is all by itself already, so we can take the square root right away, and we have x minus 3 is equal to plus or minus 4. If we add 3 to both sides, we have x is equal to 3 plus or minus 4, which gives us x is equal to 7, or x is equal to negative 1. In contrast, a problem like number 5 has a square root, and so you undo square roots by squaring. So it's kind of the reverse of what we just did. We're going to square both sides, and we end up with 15 minus x is equal to 4. Now I'm going to do two algebraic steps at once. I'm going to add x to both sides and subtract 4 from both sides, and you end up getting x is equal to 11, which turns out it's your final answer, x equals 11. For number 6, once again we have a square root alone on one side of the equation, so we can square both sides. We have x squared is equal to x plus 56. Now, if we want to solve this quadratic, we need to get everything alone on one side of the equation and factor. We have x squared minus x minus 56 is equal to 0. With quadratics, we set the equation equal to 0 and solve from there. Now you can make a diamond, and you could put negative 56 up top, and you could put negative 1 on the bottom. Negative 8 and 7 are the two numbers that multiply to make negative 56, but add up to make negative 1. So we have x minus 8 times x plus 7 is equal to 0. Now we're going to set each of these parts equal to 0. So we're going to set x minus 8 equal to 0 and x plus 7 equal to 0. If two things multiply to make 0, each of them must be 0. X is equal to 8 or negative 7. Those are our two answers. Now for number 7, we have a similar situation going on. However, we need to subtract 6 from both sides so that we have this square root part completely alone on one side of the equation. And once you've achieved that, then it would be appropriate to square both sides. Not before that, though. Now, when we have x minus 6 quantity squared, you're going to have to put x minus 6 and x minus 6 into a box and multiply it out that way. You can't just square the x and square the 6. You can't just say it's x squared minus 36, because that would end up being incorrect. Remember, when we square polynomials, we use a box to help us remember that there's some other terms involved. So we have x minus 6 equals, now we take the factors, or the terms from our box. X minus 6 equals x squared minus 12x plus 36. I wrote 32 here, but that was a mistake. 36. 6 times 6 is 36. Good. You can see by using the box, it's not just x squared plus 36, we also have a minus 12x in the middle. Now I'm going to subtract x from both sides, and I'm going to add 6 to both sides. 0 equals x squared minus 13x plus 42. Now we can use a diamond to factor that out, and you could put your 42 up top and your negative 13 on the bottom. Negative 6 and negative 7 are the two numbers that multiply to make positive 42, but add up to make negative 13. And that ends up giving you two answers. We get x equals 6 or 7. Two answers. And both of them are perfectly good. For number 8, this is a rational equation. By rational equation, I mean that there are in the equation there are fractions, and x is involved in the fractions. I can cross multiply here. The one thing you want to remember is that you cannot forget your parentheses around these factors. Otherwise the problem is going to end up not working out how you want it to. Because the 6 gets distributed both to the x and to the minus 7. Likewise, the 4 gets distributed both to the x and to the 3. And let's see, if we subtract 4x from both sides and add 42 to both sides, I think you end up getting something like 2x is equal to 54. And if 2x is equal to 54, we can divide both sides by 2, and we get x equals 27. Okay, we can move on to the next problem. Now this one, I'm going to rewrite it with a little bit more space involved. I'm going to write 5 over m minus 13, and I'm going to leave some space, plus 10, I'm going to leave some space, equals 22 over m minus 13. The part of this problem that makes it kind of annoying is you're going to notice that there's these denominators here with m minus 13s, and really we don't want denominators with variables in there. Somehow we want to clear out those denominators. But if I multiply every single term of this equation by m minus 13, I'll clear out those denominators in no time. Cancel and cancel. And you're going to see that what we're left with is pretty straightforward. 5 plus 10 times m minus 13 equals 22. Now that's just a regular old equation that you guys are perfectly capable of solving in like just a couple seconds. That's the sort of problem that you guys have been doing since freshman year. So a problem that at first looked pretty scary turns into something that you're very familiar with. That's kind of mathematics in a nutshell, to be honest. So let's see here. I'm going to add 130 to both sides. 10m equals 147. Divide both sides by 10. And you end up getting m equals 14.7. And there's our final answer. I know I took a little extra space, but there it is. For number 10, I'm noticing a negative on both sides. If I multiply both sides of the equation by -1, we can end up just ignoring those negatives. Now we're going to cross multiply again. And it's actually the same process that we went through in number 8, where we cross multiply. It's going to be 16 times the quantity p plus 3, make sure you have parentheses there, equals 9 times the quantity p minus 4. Then we distribute the 16, and we distribute the 9. And we get 16p plus 48 equals 9p minus 36. Now I'm going to clear out some space here. Remember, if you do need the work from number 9, you could very easily just rewind the video and pause it. So no reason to leave this up here. It's just taking up space now. Okay, if we have 16p plus 48 is equal to 9p minus 36, it looks like it's a good idea to do a couple algebraic steps at once. So we end up with 5p is equal to, and then on the right side, let's see, negative 84, I believe. And if we divide both sides by 5, we have our answer. P equals negative 84 for 5. Now, I can't remember if this was supposed to be a fraction like that or not, so I'm just going to quickly double check my work. It's never a bad idea to do that. But 16 times p plus 3, 9 times p minus 4, 16p, 30 plus 18, 48, sure. 9p minus 36, yep. Subtract 9, get 5, sure. Okay, yeah, I guess it's right. I just couldn't remember if we had a solution for that one or not. Okay, if we move on to number 11, there are many, many different ways to do this problem. I could think of about 3 or 4 that would work. In my opinion, I don't really like dealing with fractions when I don't have to. So I'm going to try to multiply both sides of my equation by some number that will get rid of the denominators entirely. Basically, I'm looking for a number that 5, 2, and 4 both go into. The least common multiple of 5, 2, and 4. 20 is that number. So I'm going to multiply both sides of the equation by 20. When I multiply 20 by x over 5, 20 over 5 becomes 4, so 4x equals, when I distribute the 20 into the parentheses on the right side, 20 over 2 becomes 10, so I have 10x. And 1/4 of 20 is 5. Now I'm going to subtract 4x from both sides, and I'm going to add 5 to both sides. And you get 6x is equal to 5. And then if you divide both sides by 6, you get x is equal to 5 over 6. So other ways that you could have done this, you could have subtracted the x over 2 from both sides, and then tried to combine those fractions, and then cross multiply. I think it's probably a little bit harder doing it that way. I mean, you've got some choices, but I think the way that I just showed you, trying to clear those denominators out as quickly as possible is probably your best bet. Okay, let's move on to number 12. This looks similar to something we just did recently. with the logarithm stuff that we just learned. We have 3 to the x minus 8 is equal to 81. Now, the thing that you probably want to do now is write 81 as 3 to the 4th. If you write 81 as 3 to the 4th, then we can set those exponents equal to each other. And we have x minus 1 is equal to 4, add 1 to both sides, and you get x is equal to 5. Now, that's not the only way that you can do this. Let me show you the other way instead of just talking about it. 3 to the x minus 8 equals 81. I can write this as log base 3 of 81 is equal to x minus 8. And if you do log base 3 of 81 in your calculator, you get 4. So, a little bit worried here. Looks like I must have had something wrong. Oh, here's my mistake. I made a mistake at the beginning of number 12. I apologize for that. I wrote this as x minus 1 instead of x minus 8. Look where the red pen is. I knew there had to be something wrong here. I apologize, I'm trying to go fast so this video doesn't take up too much of your time, and so I made a little mistake. Notice that all those minus 1s should have been 8 instead, and then 4 plus 8 is equal to 12. So here's my answer, the first way of doing it. The second way should work out to the same thing, and it does. So it turned out that it was really a good idea for me to work out the problem in 2 different ways, because I noticed the mistake the first way I did it by trying it a different way. So you can use logarithms by rewriting exponential form in logarithmic form, or you could use equating exponents. If you can get the bases the same, the exponents also have to be the same. Either way is going to work. Same idea for number 13. You could either write this as 5 to the 8x equals 5 to the 1/2, because remember the square root is the same thing as the 1/2 power. And then that means we could just set these exponents equal to each other. 8x equals 1/2. If the bases are the same, then the exponents are also the same. And you end up getting that x is equal to, if you're trying to figure out how to do 1/2 divided by 8, dividing by 8 is the same thing as multiplying by the reciprocal 1/8, so you get 1/16. Now that's probably the fastest way to get to your answer, but the other thing you could do is you could still stick with that logarithm idea, and it'll work just fine. If you have 5 to the 8x is equal to the square root of 5, we can rewrite this in logarithmic form. Log base 5 of the square root of 5 is equal to 8x. That's our first step. Now remember what a logarithm asks you. Log base 5 of square root of 5 is really asking you 5 to what power is the square root of 5? And the answer to that question is 1/2. And you end up back where you started with the other method that we had. You still get x is 1/16. Number 5, again, the same trick is going to work. We could rewrite 32 as 2 to the 5th. That's probably the fastest way to get to your answer, because by equating these coefficients, or equating these exponents, 4x minus 3 is equal to 5, we solve the equation very fast, and you get x equals 2. Once again, you could use logarithms, but I've shown you that method twice, so I think I'm going to not show it to you yet again. Now number 16, I'm going to take this logarithmic equation and I'm going to rewrite it in exponential form. 7 to the 3 is equal to 2x minus 7. Now we need to do 7 to the 3rd power. You could either use your calculator, or you can remember that 7 to the 3rd is going to be 7 times 7 times 7. That's 49 times 7. And if you did 49 times 7, you could just do long division if you wanted to. You get a 3, and then a 6, and then 28 plus 6. You get 343. 343 equals 2x minus 7. That's going to mean that 350 is equal to 2x. And then if you divide both sides by 2, you get x is going to be 175. There it is. Number 7, we're going to do the same thing again with our logarithmic equation. We're going to rewrite it in exponential form. X to the 4th is equal to 81. Now, we haven't done this anywhere on this review worksheet, but it's something you know how to do. You undo a 4th power by taking a 4th root. Just like a square root is, just like a square is undone with a square root, just like a cube is undone with a cube root, a power of 4 is undone by a 4th root. And it's going to be x equals, you could either do this in your calculator, or you can remember that if 81 is 3 to the 4th, then the 4th root of 3 to the 4th is just 3. And there's number 17. Okay, let's move on to do number 18. Just looking to see how many we have left here. When using elimination to solve a system, what does it tell you about the lines and the number of solutions if you get 0 equals 0 versus 0 equals 1? 0 equals 0. What you have to think about is this a true statement or is this a false statement? Does 0 equal 0? This is a true statement. And a true statement is going to imply that you have infinitely many solutions. Now, if you're trying to remember what it means to say infinitely many solutions, what you want to remember is when you're solving a system of equations, really what you have going on is you've got two lines, and you're trying to figure out how many times they intersect. If the lines are parallel, they never intersect, and there's no solution. If the lines are the same line twice, the same line overlaps with itself twice, well, the lines intersect an infinite number of times. That's infinitely many solutions. And the last thing, and probably the most common way for two lines to intersect, is for them to hit exactly once, which is one solution. Well, look at this part B, 0 equals 1. If 0 equals 1, that's a false statement. And if the statement is false, the lines are never going to intersect. There's going to be no solutions. And no solutions is the same thing as parallel lines. Parallel lines. Okay. Let's move on to number 19. We've got a system of equations there. Now it says solve the system. I'm going to use elimination to solve this system. If you take a look at 2x minus 3y equals 5 and 4x minus 6y is equal to 9, usually the nicest way to solve a system is to just add the two equations together. But the only way for that to work is if you have a pair of opposites. If, say, 4x and 2x were opposites, or if negative 3y and negative 6y were opposites. Of course, they're not. So we need to create a pair of opposites for ourselves. I'm going to do that by multiplying the first equation, every single term, by negative 2. And that's going to give us negative 4x plus 6y equals negative 10. The second equation, I'm going to keep it the same. 4x minus 6y equals 9. And we end up getting, let's see, cancellation. Oh, 0 equals negative 1. That's a false statement. There are no solutions. If you get a false statement, there are no solutions to your system of equations. Now we can try number 20. And it looks like a similar system on the left side, but the right side is a little bit different. I'm going to multiply the first equation by negative 2, and let's see how this difference affects it. Negative 4x plus 6y equals negative 10 versus 4x minus 6y equals positive 10. When we add these equations together, 0 equals 0. That's a true statement. These are the same line overlapping with each other. The same line twice. And so there's infinitely many solutions. Infinitely many solutions. Now number 21, number 22, these are absolute value equations, and these can get a little bit confusing, especially since it's been a little while since we've done anything with absolute value equations. Look what I've got. Absolute value of 15x is equal to 15. You always start by getting the absolute value part alone on one side of the equation. Now, the only way to undo absolute value bars, the only way to get rid of absolute value bars, is to split into two equations. 15x equals positive 15, 15x equals negative 15. The way that you undo absolute value bars is by splitting up into two equations. divide both sides by 15, you get x equals 1. Divide both sides by 15, you get x equals -1, 2 solutions. And both of those are perfectly good solutions. Number 22, same idea. Now let me show you the mistake that a lot of students will make on a problem like this, and I really hope this doesn't happen to you. Absolute value of x minus 4 is equal to 7. A lot of students will say, oh, let's undo subtracting 4 by adding 4. Now that's not a bad instinct to have. You certainly are going to want to undo subtracting 4 at some point. However, we're not able to do that yet because we have absolute value bars. Sorry, I'm misspeaking here. We have absolute value bars in the way, so we cannot just add 4 to both sides quite yet. Rather, what we're going to need to do is undo these absolute value bars by writing x minus 4 equals 7, x minus 4 equals -7. We're splitting up into two equations. Now we can undo subtracting 4 by adding 4 to both sides. We get x equals 11 for one of our answers. Add 4 again. X equals -3 for our other solutions. We have x equals 11 and x equals -3. Thank you very much for tuning into this video. I hope it was helpful for you guys, and I look forward to seeing you on Monday. Have a great weekend. Bye-bye.